Hello everyone, I am Jennie o Libunao. Do you know what this image is? No? This shows the separated DNA fragments on a piece of gel. How does it happen? You will know if you keep on watching. And if you want to know who's the mother of who, or determine relatedness with different species, or a way to identify someone's DNA, which is helpful if you're solving a crime scene in forensic science. What do you think it is? Very good. It is by a widely used technique in life science laboratories, the gel electrophoresis. It separates charged molecules like DNA, RNA, and proteins according to their sizes. This separation technique is accompanied by the movement, which came from the word phoresis, means to carry across, of charged particles in a gel medium. Now, let us introduce the apparatus used in this technique. The equipment are composed of the power supply, which will generate the electric energy, the tank, which will be filled by a buffer solution, the gel, which is made of a material called agarose, which is extracted from the seaweed. And you can also see the wells in the agarose gel, where the DNA samples will be placed. And the last part of the gel electrophoresis apparatus are the positive and negative electrode located on the two sides of the tank separately. Before we proceed to the principles and procedure of gel electrophoresis, let us check your prior knowledge so that I cannot lose you in the process. First, do you know what is the charge of a DNA molecule? Is it positive or negative? Very good. It is negatively charged because it have a phosphate groups having oxygen ion in its bond, which is negative. Second, what do you think is the reason why the sample wells is located at the side of negative electrode? Very good. It is because when the sample DNA, which is negatively charged, loaded to the side where negative electrode is located, it will be repelled and it will travel towards the positively charged electrode because of attraction. Now, let us have an analogy of the process. Are you familiar with a sieve that is found in our kitchen? The sieve will be our agarose gel, having a mesh which separates the particles from larger to smaller ones. The larger particles will be retained or takes longer to pass through from the mesh, while smaller particles will escape easily at short period of time. In the case of gel electrophoresis, the charge helps in the mobility of the loaded samples of DNA molecules. With that, let us proceed to the procedure of gel electrophoresis. First, we need to have a complete setup: the apparatus, the comb which creates the wells in the gel, the DNA samples, micropipettes, and the loading die. After that, let's start with having the casting tray of a ready agarose gel and its well loaded with the buffer solution, followed by the sample DNA loaded using the micropipettes, and add a colored loading die because the DNA is colorless, making it hard for us to see its movement if not. Then, it's time for us to turn on the power supply generating the charge, and better conducted by the help of buffer solution, and let us turn it off when the die nearly reaches the other end. At the end, this is what it looks like. With the aid of UV light and the ethidium bromide in the gel, which binds to the DNA molecules. Now that we already have the end result of gel electrophoresis, which do you think is the larger DNA molecules and the smaller among them? This that's closest to the well? Or this that's closest to the other end? Very good. It is the molecules that is farther from the well which is shorter, while the closer to the well is larger because of its size that takes difficult time to pass through the pores. Lastly, we can determine the sizes of the DNA molecules in the agarose gel using the standard chart called DNA ladder. And that's it! You can now use it to find out what you're solving in forensic science and relatedness of organism. Thank you very much for listening. I hope you learned something.